welcome back to my YouTube channel. So now I am going to tell you about probability generating function. In short form it is called as PGF of Poisson distribution. Okay, so PGF, that means probability generating function, is denoted with Px of t. Okay, so Px of t, its formula is nothing but, in expectation we can write, in terms of expectation we can write expectation of t power x. Okay, we all know that expectation of x formula is nothing but summation x into p of x. Okay, so this is Poisson distribution is discrete distribution, so that's why here we get summation. If it is continuous we will get their integration, but Poisson distribution is discrete distribution, no? So that's why here we take summation. Okay, so that means this term we are going to write in this way. So summation x, in the sense what, in place of x we are having t power x, so t power x into p of x. P of x means what? Probability Poisson distributions mass function we have to write. So Poisson distribution mass function, that means formula is nothing but p of x equals to e power minus lambda into lambda power x by x factorial, and its limits are from 0 to infinity. So x equals to 0 and so on up to infinity. So that's why here what we have to take is summation x equals to 0 to infinity t power x into p of x, in the sense this formula we have to write. That means e power minus lambda into lambda power x by x factorial. Okay, so now what we have to do is we have to take this term as common. That means we have to make it as a constant. Why? Because here we are not having any x terms in order to substitute this x limits, so that's why we have to make it as a constant. So e power minus lambda into summation x equals to 0 to infinity, and if you observe here t power x and lambda power x, we are having powers are same, so that's why we will write as one term. That means t into or lambda into t to the power x, okay, by x factorial. Okay, so now we are going to substitute this limit, x limits, e power minus lambda, so lambda into t whole power 0 by 0 factorial plus lambda into t whole power 1 by 1 factorial plus lambda into t whole square by 2 factorial plus and so on. Okay, so and the next is, now what we have to do is lambda into t whole power 0, in the sense nothing but what, their x power 0 is nothing but 1, isn't it? So 0 factorial is also 1. Okay, so that means e power minus lambda into here 1 by 1, 1 by 1 in the sense what, nothing but 1, plus lambda into t whole power 1 by 1 factorial plus lambda into t whole square by 2 factorial plus and so on. Okay, so here if you observe here e power minus lambda, here we can write e power lambda t. Okay, why we have to write this one, in the sense here e power x formula is nothing but 1 plus x by 1 factorial plus x square by 2 factorial plus and so on. Okay, so that's why in here if you observe here x, this is x 1 factorial and x square 2 factorial, that means what is the value of x, lambda t, so that's why e power x, in the sense we have written here e power lambda t. Okay, so that equals to e power px of t, that means probability generating function formula is e power minus lambda into e power lambda t. Okay, so now what we have to do is we have to calculate mean and variance for this probability generating function of Poisson distribution. Okay, so mean in the sense, mean is denoted with what we have to denote, mu1 dash, no? So calculating mean of Poisson distribution. Okay, so it is denoted, mean is denoted with what? Mean equals to mu 1 dash. So mu 1 dash equals to nothing but d by dt of px of t. With respect to t equals to 1, we have to take probability generating function. With respect to t equals to 1, we have to take, okay, 0 we should not take. Okay, so px of t equals to, with respect to 1. So what is px of t value here? E power minus lambda into e power lambda t. So d by dt of e power minus lambda into e power lambda t with respect to t equals to 1. So here we are not having t term. So that's why we have to make it as constant. So e power minus lambda into d by dt of e power lambda t with respect to t equals to 1. Okay, so e power minus lambda, so it is in the form of e power x. E power x is nothing but e power x only if we do derivation. Okay, but the t coefficient is, we are having what? Lambda. So that's why what we have to do is nothing but lambda into e power lambda t with respect to t equals to 1. Nothing but, I will tell you one example. E power x in the sense e power x only. But e power 2x in the sense what we will write? 2 into e power 2x we will write, no? So that's why in this way we have written this one. Okay, so now what we have to do is we have to substitute t equals to 1. Okay, so e power minus lambda into e power lambda into 1. So the final answer is e power minus lambda into e power lambda. So e power lambda, minus lambda, e power lambda get cancelled. So that's why mu 1 dash, that means mean equals to mu 1 dash equals to lambda. Okay, so this is the final mean answer. So now what we have to do is, now we have to find out the variance. Okay, so variance. So variance is denoted with mu 2. So what is the formula? Mu 2, generally variance formula is mu 2 equals to mu 2 dash minus mu 1 dash whole square. But probability generating function variance formula is different. That is nothing but mu 2 dash plus mu 1 dash minus mu 1 dash whole square. So this is variance formula in probability generating function. Either it may be Poisson distribution, binomial distribution, geometric distribution, hypergeometric, negative binomial, whatever it may be, probability generating function when we are going to do, its variance formula is this one. Okay, so in order to get this one, mu 1 dash value, we all know that it is lambda. So now we have to find out mu 2 dash. So mu 2 dash formula is mu 2 dash equals to d square by dt square into px of t, where t equals to what? 1. Okay, so this one we can write d by dt of, again d by dt of px of t, where t equals to 1, sorry, okay, 1. So d by dt of px of t, in the sense here we have find out, isn't it? This value we have to write in place of this. Okay, so d by dt of, again no need of doing. If you want you can do, nothing wrong in it, but why to waste the time? So already we have find out this one, so that's why I'm going to substitute this one. Okay, so lambda into e power minus lambda into e power lambda t, where t equals to 1. Okay, so now what we have to make constant here? Lambda into e power minus lambda is constant. Lambda into e power minus lambda is constant. Why? Because t terms is not there in these both terms. Okay, so d by dt of e power lambda t. Okay, So with respect to t equals to 1. So that equals to lambda into e power minus lambda. So d by dt of e power, it is in the form of same like this, e power x. So e power lambda t, we can write what? Lambda into e power lambda t, where t equals to 1. So now we have to substitute in place of t 1. So lambda into e power minus lambda into lambda into e power lambda into 1. Okay, so here lambda into e power minus lambda, lambda into e power lambda, lambda into 1 is nothing but lambda, so e power minus lambda, e power lambda get cancelled. So mu2 dash answer is nothing but what we got here, lambda into lambda is nothing but lambda square. So now what we have to do is we have to substitute in this way formula. So mu2 equals to mu2 dash in the sense what? Lambda square. Mu2 dash in the sense what? Lambda square. So lambda square, mu1 dash in the sense what? Lambda. Mu1 dash in the sense lambda. Okay. So lambda minus lambda whole square. So mu2 equals to lambda square plus lambda minus lambda square. This both gets cancelled. So mu2 variance that equals to lambda. So in Poisson distribution, mean and variance both are same. That is nothing but mean equals to lambda, variance also equals to lambda. So this is about what? Probability generating function of Poisson distribution. Hope you all understand. So if you get any doubt, please comment. If you like also, please comment. Okay, so and if you are newly watching this channel, please subscribe to my channel for latest videos. Thank you for watching and share with your friends. Thank you. Have a nice day.